Welcome back. We are continuing with the problem. Now we will discuss about how to find the type of singular point. So we have already find out the type of singular point as stable focus from the shape of the phase trajectory. Now you can also find the type of singular point using the Jacobian matrix. So for this, first we have to linearize the given set of equation using Jacobian linearization method around the singular point. So Jacobian matrix is a matrix like this. So this is our Jacobian matrix. This is a general form, and here it is since it is a second order system, since we have only x1 and x2 variable, we can write our Jacobian matrix as dou f1 by dou x1, dou f1 by dou x2, dou f2 by dou x1 and dou f2 by dou x2. Now what is f1? f1 is the function 1. Function 1 is actually x1 dot is equal to x2. That is our first state equation is our first function. What is f2? f2 is the next state equation. Now apply these equations here. Now what will be our matrix? Our matrix will be like this, that is dou by dou x1 of function 1, that is dou by dou x1 of x2, dou by dou x2 of x2, dou by dou x1 of minus x1 minus 0.3 x2, dou by dou x2 of minus x1 minus 0.3 x2. Now if you differentiate this with respect to this equation, we will get 0, 1, minus 1 and minus 0.3. Now this is our system matrix now, and these matrix do not contain any value, or this matrix do not have the elements with x1 or x2. All the elements in this matrix are constant values. So we can directly take this matrix. Now the next step is finding the eigenvalues of the system or the corresponding matrix corresponding to the singular point 0, 0. That means at 0, 0, since this matrix have only constant values, we can directly take this matrix. And at 0, 0, that means at singular point, our matrix is like this. If this matrix is having elements like x1 or x2 or 2x1, we have to substitute for x1 and x2 0, 0 and find the values of the matrix, new matrix here. Then only we will be able to find the eigenvalues and the type of the singular point corresponding to that eigenvalue. Here we can directly take, because this equation only contains constant values. So at 0, 0 or at singular point, our matrix is like this. Now find the eigenvalues. So if you find the eigenvalues, we will get an equation like this. This is the characteristic equation of the matrix lambda I minus j, and our eigenvalue is minus 0.5 plus or minus j.98. So if you check the type of singular point, you can see that this is a complex conjugate eigenvalue with a negative real part. So if the eigenvalues are complex conjugate and having a negative real part, that means the type of singular point is stable focus. That is the answer for that. So we can directly write the equation, find stable focus. But if they ask us to find the type of singular point using method of phase trajectory or plotting the phase trajectory, we have to follow that only. So our type of singular point is stable focus.